We've been looking at radicals today. We're going to look at the properties of radicals. We want you to be able to simplify radical expressions using these properties. So radicals, that's just another name for some type of root, whether it be a square root or a different type of root that we'll be looking at today. The product property is one that we're going to be looking at today. That says if you have two things in any type of root, you can split those up if the numbers inside the root are being multiplied. So example, if you have square root of 16x to the fourth, since 16 is being multiplied to x to the fourth, we can think of that as square root of 16 times square root of x to the fourth, and then we should be able to take the square root and figure it out. Square root of 16 is 4. Square root of x to the fourth would be x squared, and then that would be your answer. Okay, same thing with dividing. Quotient property says if you got a square root of a fraction or two things being divided, it's the same as the square root of the numerator over the square root of the denominator. So if you had, say, square root of 36 over x to the sixth, we could split that up over as square root of 36 over square root of x to the sixth. Then we can just simplify each square root. Square root of 36 is 6, and then square root in the denominator of x to the sixth would be x cubed. So that's the quotient and product property of them. So we're going to use those to do some different radical problems here. Remember though, when simplifying a radical, we try to a lot of times avoid having radicals on the bottom. It's not necessarily wrong if you leave one there, but a lot of times, especially on the ACT, the multiple choice answers have it where that is not there. So we don't want, if there is no radicals in the answers, then we'll look at how you can get rid of that. So we'll look at how you would simplify something like that. Okay, so if you want to what's called rationalize the denominator, you want to try to get rid of it. So if we use that same property we just did, what we want to do is say it's square root of 9 over square root of 5. Now what's nice about this one is the top we know is 3, but square root of 5 is not a perfect square. So this would be the answer to the problem. However, if all your multiple choice answers don't look like that, that means what they did is probably they what's called rationalize the denominator. So how you can get rid of the square root in the denominator is to multiply by that same thing. So if we multiply by square root of 5, that will end up getting rid of that square root. But here's the thing, whatever you multiply to the bottom, you also have to multiply the top as we've done with other problems. So this will end up then equaling 3 square roots of 5 over, on the bottom we got square root of 5 times square root of 5, that's the same as square root of 25, and we know the square root of 25 ends up equaling 5. So this is the same answer, just with a rationalized denominator. So if all your answer choices didn't have a square root in the bottom, then you'd want to rationalize it, and I'm sure that answer would be there. Let's try one with a cubed root. So on the second problem, we'd end up with a cubed root of 2 over the cubed root of 9. Okay, so on these problems, if it's cubed root, then you got to multiply and get rid of that by doing 2 more of them, because to get rid of a cubed, you would need 3 of the same thing. So we'd want to multiply by not just 1 cubed root of 9, but 2 of them. Because if you multiply 3 of the same thing, then that would just end up equaling on the bottom what's under that radical sign of 9. Okay, just like when we multiplied square root of 5 and square root of 5, it ended up equaling just 5. So with cubed root, you need a total of 1, 2, 3 of the same things. Okay, well, we ended up multiplying 2 of these cubed root of 9s to the bottom. That means on the top, we also got to multiply by 2 cubed roots of 9. Otherwise, we're changing the problem. So now on the top of this one, we would end up with the cubed root of, and then we'd want to see what is 2 times 9 times 9, and whatever that is, that would be what's on top. 9 times 9 is 81, times 2 would be 162. So now this would be the answer with a rationalized denominator. All right, let's try some more of these problems. So we're just going to work on simplifying different radicals the rest of these notes. So square root of 198. Well, 198 is not a perfect cube. So what we want to do is look and see, is there any perfect cubes that go into that? Remember our perfect cubes being like 4, 9, 16, 25, 36, 49, 64, 81, 100, and you know it keeps going here. So do any of those numbers divide in 198? Well, I believe 9 goes in there. So if we take 198 divided by 9, it's 22. So another way we could write this problem would be square root of 9 times 22. 9 times 22 is 198. Then using our product rule, we can split it up as square root of 9 and square root of 22. And we know square root of 9 simplifies to 3. So the answer would be 3 square roots of 22. All right, the next one, 3 times the square root of 54. Now it looks like this one was already simplified a little bit, but it must simplify even more. So what's a perfect square that goes in 54? I think 9 does again. So we can write this as 9 times 6 is 54. So now we got square root of 9 times square root of 6, and we know square root of 9 simplifies to 3. So now we got 3 times 3, and we can write that as 9 square roots of 6. 9 square roots of 6 is the same as 3 square roots of 54. It's just simplified more because we got more stuff out of that radical sign. All right, number 3. This one now, there's some variables start getting added. So we want to think about, okay, let's start with the number. What's a perfect square that goes in there? 128. I think if we divide that by 2, we get 64, and 64 is a perfect square. So 64 times 2 is 128. Okay, it's also being times by x to the 4th. Okay, and we can take square root of x to the 4th, and that'll turn out nice. And then we get this y to the 3rd power. Now, square root of y to the 3rd power does not come out nice because remember when you're doing square root, it's like there's a little 2 there, and 2 doesn't divide into 3. So just like we did with the number, we're going to split the y up as well. We're going to split the y up as 2 and 1. That's still 3 y's under the square root. It's just that we want an even number for our exponent. All right, so now let's split this into 2 radicals. One radical will be the stuff that we can simplify. So we'll leave everything we can simplify in 1, and then times, and this other one we'll put the stuff that does not simplify. So the stuff that will simplify, 64, we can take square root of that, that'll come out nice. X to the 4th, that'll simplify nice, and the y squared will simplify nice. The stuff that's not going to simplify out of this is the 2, and then the single y. Okay, that stuff won't. So now simplify what you can. Square root of 64, that's easy, 8. Square root of x to the 4th is x squared. Square root of y squared is 1y. This stuff on the right one, though, doesn't, so we'll just leave that in the radical sign. And there's our simplified answer. So you want to try to separate the stuff that does simplify with the stuff that does not simplify. All right, number 4. Now this has 2 radicals being multiplied. We know from the property we could combine this into a single radical first. So let's do that. So if we take 24 times 12, that's 288. We got x to the 6th with another x, that's going to end up being x to the 7th. and we got y to the third and another y, that's going to be y to the fourth. Okay, so we put it back together. Now let's try to separate out anything that's going to simplify here. Well, 288, half of that's 144. 144 is a perfect square. So let's split that as 144 times 2. X to the 7th isn't going to simplify nice because, again, when we have a square root, it's like there's a 2 there. 2 doesn't divide into 7. So let's split that up as 6 and a 1. That's still 7x's, but x to the 6 will simplify. Y to the 4th is going to simplify nice for us. So now, again, split it into one that will simplify. Simplify. And one that does not simplify. Okay, stuff that will simplify, 144 does, 2 doesn't. X to the 6 will simplify, X doesn't. Y to the 4th does simplify, and we're done. So now simplify what you can. Square root of 144 is 12. Square root of x to the 6 is x cubed. Square root of y to the 4th is y squared. Stuff that doesn't simplify, we just leave in the square root sign. There's the simplified answer for that one. Okay, on the back, some more examples. Number 5, now we're doing that quotient property. So anytime there's a quotient, we want to say it's going to be the square root of what's on top over square root of what's on bottom. Okay, now you want to try to, again, simplify anything you can here. So on top, 18 is the same as 9 times 2. 9 being a perfect square. So let's chop that up like that. Bottom, I don't think that 7 one is going to simplify, but I think y squared will be. So let's separate those into the things that will simplify and the things that won't. And that top, the stuff that will simplify is the 9x to the 4th. The 2 will not. On the bottom, y squared will simplify, square root of that, square root of 7 will not. So your answer would be 3x squared, square root of 2, over y, square root of 7. So that would be the answer there. Now, if this is an ACT question and you get that answer, but that doesn't match up with any, it may be that they rationalize the denominator. So if we want to rationalize the denominator on this one, multiply both top and bottom by square root of 7 to get rid of that square root on bottom. So then our answer would become 3x squared. If we multiply these together, that'd be square root of 14. On bottom, square root of 7 times square root of 7 is square root of 49, which equals 7. So you end up with 7y on bottom. So either one would be the answer. This second one would be the one with the rationalized denominator. All right, number 6. We end up with square root of 5 on top, square root of 4a on bottom. Doesn't really look like anything on top simplifies. On the bottom, though, we can separate that into stuff that will and stuff that won't. Square root of 4 ends up equaling 2. Okay, so that's the answer. If you want to rationalize the denominator, we'd have to get rid of that square root of a, so we'd multiply both top and bottom by square root of a, and we would get square root of 5a on top. On bottom, we'd get 2, and then square root of a times square root of a is a. So that would be the answer with the rationalized number. So this is the rationalized answer. The one on top, one above it would be the one that's not rationalized. All right, number 7. Again, it's a fraction one, so we want to say it's square root of the stuff on top over square root of the stuff on bottom. Okay, now we want to split into stuff that will simplify and stuff that won't simplify. So on top, again, when it's square, we want an even number there, so let's split it up as m to the 8th and another m, that's 9. On bottom, let's do n to the 6 times another n. So now I'll write the stuff that will simplify in one, stuff that won't simplify in another one. Same on the bottom. N to the 6 will simplify, the last n will not. And so our answer would be, that simplifies to m to the 4th. On the bottom, that simplifies to n to the 3rd, but then we still have these two square roots that don't simplify. So that's the answer. If you want the answer with the rationalized denominator, then we got to multiply by that one on the bottom. So we'd multiply by the square root of n to both top and bottom. And we would end up with, on top, square root of m times n, and that square root. On bottom, square root of n times square root of n would be another n. And we could even go one step farther here, since we got another n on the bottom, we could write that as n to the 4th power. So this answer's the same as the answer here, it's just rationalized. So depending on how they have the answer on the ACT, you may or may not want to rationalize. All right, number 8. Now this one is a different root. It's not a square root, it's a 4th root. Okay, so we wanted to start by doing the same thing. This is the same as the 4th root of 3x over the 4th root of 2. Okay, so that neither of those are perfect roots to the 4th. If we want to rationalize the denominator, though, then we need to multiply. So since it's to the 4th power here, if you want to rationalize it, you need a total of 4 being multiplied in order to get rid of the root. So if we want to rationalize this one, we got to multiply by 3 more of these cubed root of 2's, because now we have a total of 1, 2, 3, 4. So if you have 4 of those, that will then simplify to, on the bottom, just 2, because you got 4 cubed root, or 4th root of 2's being multiplied. That would just equal 2. But whatever we multiply to the bottom, we also need to multiply to the top. So on the top, we also need to multiply by 3 more of these. So on the top, what we'll end up with is the 4th root of 3x times 2 times 2 times another 2. Now we just got to simplify that. That would end up equaling 3 times 2 is 6, times another 2 is 12, times another 2 would be 24x over 2. So that would be the answer with the rationalized denominator. All right, number 9, we got a bunch of stuff going on here. So since there's 2 4th roots here, we should be able to combine those into 1. We also have these 2 numbers outside the root. We should be able to combine those. So let's start there. 5 times 4 is 20. And now let's combine this stuff together. So we should be able to multiply 24x to the 3rd times 54x and see what that simplifies to. So if we do that, that's going to be 24 times 54 is 1,296. And x to the 3rd times another x is x to the 4th. Okay, now we want to look. Does that simplify any farther? Well, let's see what the 4th root of that is. Remember, on your calculator, you want to use that x square root one. So I have to hit 4 first, since I want to do the 4th root. Find that one that has the x square root. Here it's number 5, the 5th choice. Okay, now it'll do the 4th root. Let's see what the 4th root of 1,296 is. Looks like it equals 6. So this equals 6. Now let's see, what's the 4th root of x to the 4th? Well, remember, when you're doing roots, you're actually dividing. So if we take 4 divided by 4, that's going to be x to the 1st power. All right, now the last thing we want to do is just multiply these 2 numbers together. The answer would be 120x would be what this simplifies to. All right, let's try one more of those. Why don't you pause the video, try this one out, see if you can simplify number 10, see what you get. All right, let's check it. On this one, we should be able to multiply the two numbers. That's 21. And we should be able to multiply these two cubed roots together. 75 times 45 is 3,375. A to the fourth times a squared is a to the sixth. Okay, now we want to simplify this. If you did the cubed root of 3,375, that should have came out to be 15. And the cubed root of a to the sixth is going to be a squared. And then if you multiply those two numbers together, the final answer is 315 a squared. All right, try some of these out on the practice.